Today's lesson is going to focus on finding missing parts of a linear equation. We're going to be taking a look at trying to describe a linear equation as best as we can in a number of different ways. So just as a reminder, that a linear relation is a pattern, okay, that steps up or down by the same amount each time. Okay, so we're going to have a pattern that's either going up or down by the same amount. It could go up by 5s, it could go up by 1s, it could go up by 10s. It's always going up by the same amount each time. They can be shown in a table of values or graph, and they can be written or described as an equation, okay, to solve for future values. So there's a few different ways that we can represent it. We're going to be taking a look at all three of them and how we can kind of go back and forth between all three of those ways of displaying it. Each method of displaying the linear equation can be used to solve, okay, or display the other two. So we're going to try to use each of those methods in order to display or solve for the other ones. We're going to start with when we're given a table of values. So in this case here, I've given you a table of values, and we're going to try to figure out the rest of it from that. So when a table of values is given, the graph, okay, can be drawn directly from the points given. Okay, so we can draw the graph directly from those points given. Just all we need to do is create our graph and kind of go from there. Now what you'll see with this graph here, we have this table of values. It's all positive values, so I'm not even going to do the negatives at all. I've got to get up to 12, and I have 14 spaces here, so I can easily put that all together. And what I'm going to do is I'm going to draw out my graph like this, showing that there is, in fact, negatives as well. I'm not going to leave them out because there is no context to this, so negatives could, in fact, be true. And I'm going to go up by 1s. 6, 8, 10, 12. This is the y-axis, this is the x-axis. All right, there's my fully labeled graph. Okay, I have my x and my y on there. I've labeled which is x and y, and I have arrows that display that as well. Now, to draw it out, we're just going to plot these points. The first point is 1, 4. That is right there. 2, 6, right there. 3, 8 is over here. 4, 10. And what you will notice is that all of these here, I'm going to quickly label them as well. This is 5, 12, 4, 10, 3, 8, 2, 6, and 1, 4. They're all labeled. Okay? They're all going to end up in a straight line. Now, because we don't have any context to kind of say if points do or do not work, all these points are considered to work, and everything in between is as well. So we are going to draw in a line that joins all of these points together and put arrows at the ends of our lines. Now we can probably try to estimate some other points as well. We can do that using the graph or using the table, but that is a way of creating our table of values. Now again, plotting these points, remember that each of these points is a point on the graph. Okay, it always goes x, y, and each one of them is on there and again labeled as well. Draw a straight line through there. If it's linear, which all the ones that we're going to do today are, we are going to have a nice straight line that goes through those points. Now, the graph should be fairly straightforward, as we've done a lot of that in the past. The coming up with an equation from a table of values can be a little bit more difficult. What we're going to do is we're going to use graphic form whenever we have a table of values. Okay, and actually we can use graphic form when we have a graph as well, but we'll get into that a little bit later. The first thing that we need to do is we need to determine the change in y based on x changing by 1. Now if x is going up by something other than 1, we need to divide the change in y by the change in x, and I'm going to go through just an example of that on the side, but because we may come up with that later, we may not. So when we look here at our table of values, we want to look, how is the y changing? Well, every time the y is going up by 2. So our change in y, and we've talked about this a little bit, this is our m value. Okay, I'll let you know about that later. Y is going up by 2 every time x goes up by 1. So our m is going to be 2. Okay, that's going to be our 2. Or, sorry, that is going to be 2. The second thing that we're going to take a look at is we want to find what I call the 0th term, or the starting point, by going backwards in the chart, or using the value that you found in number 1 and multiplying it to an x value and calculating the difference with your y value. Now we can also use our graph as well. If we look at our graph, where does the line cross here? It crosses at 2, or it looks like very close to 2. If we go back here, we're going to our 0th term, which will go back 2, so it would be 2. And we're going to use this. This is our b value. B is equal to 2. Okay, that's our starting point. Now when I talk about that second part there, what we can do is, if we are multiplying this value to anything here, so if we multiply 5 times 2 gives us 10, we have to add 2. 4 times 2 is 8, plus 2 is 10. 3 times 2 is 6, plus 2 is 8. We're always adding 2, so that's going to be our b value. That would be another way of going through it and trying to solve for it. Now once we have these two values, we're going to use what we call graphic form, which we've looked at in the past. Okay, there's graphic form, and we're going to create an equation from that. Okay, our equation, we're going to take our m value, put it in here, y equals 2 times x, and take our b value and put it in here, times 2. Okay, so it's 2x plus 2, and that would be our equation for this line. Now I talked about how do we change things if all of a sudden it's not a 1, and we're going to look at that on the next slide. When we go through that. So that's how we come up with an equation. Now we're going to take a look at a couple more examples before we get into the assignment here, which is already on the side. But what we're going to do is we're going to take a look at these ones here. So let's create an equation, and again we're going to use y equals mx plus b. We're going to use graphic form in order to do that. First thing we want to do is, how is the y changing? Well, the y is going down by 6. Okay, so we're always going down by 6 every single time. Now, that would be all fine and dandy, but the x is not always going up by 1. The x is going up by 2s every single time instead of up by 1, which makes it a little bit more difficult to figure out what our m value is going to be. But it is consistent, so it's always going up by 2, so that's the important part. Okay, now to find our m, what we're going to do is we're going to do something called, and I'm going to put this up on the top as well. Okay, we're going to get into more of this in grade 10, but I want to go through a little bit of it right now. Okay, it's the change in y over the change in x. Okay, so the y is going down by 6 every single time, and the x is going up by 2, so it's a positive. And what we can do is that we can simplify this, and when we divide, this gives us -3. That means that we have a change of -3 each time. So every time x goes up by 1, y is going down by 3. Now our b value is when y is equal, or x is equal to 0, and that's actually given here already, which is super nice. Okay, so our b value here is 2. Now once we know our m and our b, we can put them into our form. Y is equal to -3x. Okay, we're multiplying those two together. And then this is a positive, so we are adding 2 onto that side there. All right, let's do the last one here. Okay, so we have another one here. Let's take a look at our change. So we are going up 10, and it keeps on going on and on. These are going up by 5. We're adding 5 each time, and that continues on and on and on. So our m value, change in y is 10, change in x is 5, so our m value is 2. Now, what is our zero value? Well, now that makes it to be a little bit more of a challenge because our zero value, okay, is way far away. We're not given our zero value. But once we know our m, what we can do is we can take any one here. And I'm going to take this one here. 2 times 65 is equal to 130. What do we need to put in here so that this equals 50? Okay, so we're multiplying the 2. That's where the 2 comes from. Put that in there. 2 times our x, 65, equals 130. What do we need to do to get to 50? We need to subtract 80. Now, if you're not sure about that, let's take another one. Let's take this one here. Okay, 2 times 50 is equal to 100, minus 80 is equal to 20. So we're always subtracting 80, so our b value is negative 80. Now, that seems like a really big number, and that's okay. So our equation is y is equal to 2x minus 80. And that's going to be our equation for this line. And I'm sorry that the assignment part got in the way. I put that in the wrong spot before we got started. But this is how we can come up with our m and our b. Sometimes we can do a little bit of practice, and we create our equation. That equation gives every point that is on that line. Now, for those of you that are following along in the notes here, you can take a look at assignment LR4, question number 1. It gives a bunch of tables of values, and you have to come up with a graph or graph it out, and just use line paper for that, or graph paper if you have. And then you need to also create an equation which represents the pattern as well.